Right here we want to evaluate the negative of the square root of 81. Well, if we just focus on that right there, the square root of 81 is 9. Because if you take 9 times 9, that equals 81. So if you have the negative square root of 81, then you have the answer as that. So it's the negative 9. Right here we want to approximate the square root of 94 to the nearest tenth without a calculator. So here in red listed is the first 10 perfect squares, square roots of perfect squares. And if you look at the square root of 94, that would fall in here. So if we look at the square root of 81 and square root of 100, the square root of 94 falls somewhere in between there. Well, the square root of 81 is 9, the square root of 100 is 10, so we know that the square root of 94 should be in between 9 and 10, so 9 point something. Well, let's look at how far away 81 and 94 are. 94 is 13 units away, and then 94 to 100 is 6 units away. So we know that it is closer to 10 than it is closer to 9, so it's got to be more than 9.5. So we know we're going to put 9 point, I don't know, like we could say like 9.7, or maybe even 9.8. When we're solving an equation, we want to find out what the variable is. Currently, C is being divided by 4. Well, we need to undo that, do the opposite. The opposite of dividing by 4 is to multiply by 4. What you do to one side, you've got to do to the other. So we've got basically 4 over 1 times C over 4 equals 16 times 4. These can simplify to 1, so you're left with just C on the left side, and on the right side we have C being equal to 64. Again, here we want to look at the side of the variable. We want to figure out what the B equals. So we need to undo the adding by 4.35. So I'm going to subtract 4.35 from both sides. When you do that, B is left by itself on the left, and on the right side we get negative 6.6. Okay. Again, we want to find out what the value of G is. If we look at the side of the equation with G, we see that it's being multiplied by 2, so we're going to have to undo that at some point in time, and it also has 13 being subtracted from it, so we're going to have to do the opposite of that. I'm going to start with that. So I'm going to add 13 to both sides. Gives us 2G is going to equal 3 plus 13, which is 16. And now G is being multiplied by 2. The opposite of multiplying by 2 is to divide by 2, but what you do to one side, you got to do to the other side to keep it balanced. So we got G is going to be equal to 8. Alright, so here we got P's that are on the same side of the equation. We want to get the variable on the same side of the equation and by itself. It's already on the same side, we just have to simplify or combine the like terms here. When you put negative 2p with positive 11p, we get 9p. We still have 72 on the right side. Now we want to undo multiplying by 9, which is divide by 9. But you do one side, you got to do to the other to keep it balanced. 9 divided by 9 gives you 1, so we have 1p on the left. On the right, we have 72 divided by 9, which is 8. Again, we want to get the variable on one side and by itself. In this example here, or this problem in number 7, we've got, here's 5a, and I'm going to keep the sign just to the left of it, so negative 3a. Those are like terms. If I group those together, if you have 5a, take away 3a, you're left with 2a. We still have that plus 3, and it all equals negative 7. We want to continue to work to get a by itself, so we got to subtract 3 on both sides. So we get 2a on the left, and we get negative 10 on the right. Opposite of multiplying by 2 is divide by 2, so divide both sides by 2. And we have a equaling negative 5. Alright, on this we want to work to get it more simplified. We got to get rid of the parentheses. And also in the order of operations, we have to multiply before we add. So going to focus in on this right here because that's multiplication. Then we'll worry about adding. Well, we got to do 4 times z, which is 4z, and then 4 times that 5, which is 20. I'm going to bring down this 3, and then this still all equals 31. Going to simplify the left side of the equation. I've got 3 plus 20, which is 23. We got that plus 4z equals 31. Working to get z by itself, we still have to undo adding by 23, so I'm going to subtract 23 on both sides. Gives me 4z on the left. On the right, that gives me 8. Divide both sides by 4. So z is going to be 2. Alright, so we want to write an equation for this function described. It says the output of a function is 7 more than. More than means addition. So we're going to have to add 7. 3 times means multiplication. The input, we don't know what the input is, so let's just use a variable. I'm going to call that x. So we have 3 times x. So here we have 7 more than 3 times x. All of that should equal -8. So there's our equation. Now we just got to work to figure out what x is. So I'm going to subtract 7 from both sides. I get 3x on the left. On the right, you get -15. Divide by 3, divide by 3. So x is going to equal -5. Alright, here we have a ticket agency sells tickets to a professional basketball game. The agency charges $32.50 for each ticket. So $32.50 for each ticket. A convenience fee of $3.30 for each ticket. And then a processing fee for the whole order of $5.90. The final charge is going to be $220.70. So I'm going to start here by combining the like terms. So if we put together $32.50 and $3.30 together, we get $35.80x plus $5.90, and that still all equals $220.70. Going to work to get that x by itself, so I'm going to subtract 590 from both sides. That gives me $214.80, and I have 35.80x. Going to divide both sides by 35.8 and the other side as well. And when you do that, we're going to find out that it's going to be 6 tickets.